Hello, I'm dgerard, and this is Pivot to AI. Today, we've got a guest post on the blog, The Futile Future of the Gigawatt Data Center. And we're doing an actual podcast interview with the author, Dr. Nicholas Weaver. I know Nick as a longtime fellow Bitcoin hater, and we're recording on Zoom, so excuse the video, but the sound should be excellent. Cross fingers. Nick, please introduce yourself.
So I'm a researcher focused on computer security and general systems. I've also been a lecturer for many years, although not anymore because I got laid off because teaching costs money and universities don't want to spend money. And I'm a cryptocurrency skeptic, and I'm kind of a machine learning skeptic, but not quite so much. I don't tend to use machine learning very much. And the reason why is because machine learning at heart is building a pattern matcher where you don't know what to look for, because if you did, you would just use a pattern matcher. When you're done, you still don't know what to look for, because then you would rewrite it as a pattern matcher. And it's okay to be wrong. That a machine learning system, in the best case, has a non-trivial probability of being wrong. And worse, from a security standpoint, it's wrong in both directions. It can say yes when it should say no, and say no when it should say yes. And this makes me very reluctant to use machine learning as a tool until the absolute last. I'll use it when I have no other choice and those criteria apply.
Right. So have you actually used machine learning a lot in practice? What sort of things? And have you got as far as transformers or even large language models?
So in general, no, because the problem is I tend to work in the space where I can build a pattern matcher. I am working on a problem where we are going to have to use machine learning. So I want to build a drone detection system. And we're going to use machine vision to identify this is a moving point in space. And then when you have the moving point in space, you get a close-up photo and apply the machine learning to know what it is. Now, among other things, this is deliberately constraining the space. I'm only applying the machine learning on things that I know are actually interesting, and it's the end of the pipeline. So it's very much a machine learning last approach. And also, I am, without realizing it, a very heavy machine learning user because I use things like Siri and OCR, and all those tools are basically machine learning powered.
They're basically machine learning products. They're things that have successfully moved from impressive demo to product you can use for things.
And in fact, it's a decade plus. And I use this as a test of, do you take someone seriously? If they say machine learning, listen to them. They probably know what they're talking about. If they say AI, take it with a grain of salt, because they may know what they're talking about and realize that they have to use AI because it's the hyped word, or they might be a bovine excrement artist. If, however, they say AGI, you know they are a bovine excrement artist.
And probably a cultist.
I Cthulhu Fatagan.
Oh God, have you read the sequences? Indeed. But yeah, ML is useful when it's a product and when it's being in a strictly assistive role and so on. Like transcription works great
Yeah.
to some
And
extent anyway. You have to check it every time. It messes
yes,
up every few hundred words.
yes. And that's a
This is
case
amazing.
where it's okay to be wrong. That transcripts, human transcriptors make mistakes too. Speech recognition is the classic example of the machine learning success story. Basically, computer scientists tried for 2 generations plus to do speech recognition in a systematic basis. And machine learning just works, mostly, enough.
It
And the
works
thing
enough.
is, it doesn't just work enough, but you look at it and the humans make similar mistakes too. So like Siri, the bleep will sometimes confuse 15 and 50 when I say set timer for 15 minutes, but humans do that too.
Yeah. And the way I look at it is ML is the stuff that actually does work, and that's the problem when it's used to abuse people.
Yeah. Um, that machine learning.
LLMs don't work, so they sort of mess up as the way they actually work.
Machine learning is a great way to teach a computer to be a racist a-hole, and apparently a lot of people like it that way.
Yeah,
Um,
isn't it great?
yeah, but the thing is with machine learning under the hood, it's been a revolution in the past decade and a half because of the graphics cards. That
Oh
machine
yeah.
learning mathematically, it's all just dense matrix multiply, taking a gazillion numbers, multiplying them by a gazillion numbers, adding them all together to get a gazillion numbers. Um, and this is very regular math. And computers, your CPU is good at math, but not good at doing a truly staggering amount of math. But if you want to do a truly staggering amount of math, and the math is very regular, 1 times A, 1 times B, 1 times C, 1 times D, 2 times A, 2 times C, 2 times C, 2 times D, you can do much more efficient designs. And this is what graphics cards do. And for the machine learning, you can even make more specific designs because the thing is with machine learning, it's allowed to be wrong if you're using it right. And if you're allowed to be wrong, be a little more wrong and drop the cost a lot. So when you're, say,
This is in your
modeling,
post as well.
yes. So when you're modeling, say, a nuclear weapon, you're using 64-bit math. And
Yes.
so 2 to the 64 is just a gobsmackingly large number. And so the number of numbers you can represent is huge. When you're dealing with machine learning, 16-bit is really good. You can only do 2 to the 16 possible values. Or even there's a lot of 8-bit stuff. So it can only represent 256 values. And NVIDIA's latest that they boast that their little box has a petaflop. The flop is 4-bit floating point.
FP4 is, you tell people about FP4, and once they understand, they look at you funny.
Yeah. Um, but it's a reasonable trade-off. Do things less quality and a lot cheaper. And at the end, you only lose a teeny bit of accuracy. And like Apple has been doing this for almost a decade now. So Siri started out as a machine learning product that was done in the cloud, that everything you said on Siri was packaged up, sent over to an Apple server. The Apple server did all the processing, sent it back. Now, the problem is central servers are expensive. And no matter how good your service is, central servers are unreliable just because the network's unreliable. And so Apple, starting 7 years ago, added what they call neural processing units, what are commonly known as TPUs or tensor processing units, to their phones, and the M series Max and so on. And these are basically accelerators designed to do just the math of machine learning. And I believe Apple's are mostly 16-bit. So a lot more math, a lot lower quality, but the amount of loss of quality on the output is relatively small. And so these days, Siri will happily set my timer when I'm in airplane mode and there's no net at all because more and more and more of it's running at the edge. Because
So
the edge is
how
just
does that kill
cheaper.
the data centers? That's what we want to get onto, the blog post.
So how does it kill the data centers? Well, then we look at the large language models. The large language model is fundamentally, and this is not a swear, but a philosophical term, a bullshit machine.
We're
That
allowed to use
is,
it philosophically and academically.
yes, that is, it is a statement divorced from true or false, that it basically is taking a huge corpus of all the text on the planet, compressing it down, and the output is a function of the compressed corpus of all the text on the planet and the input. And these things are big because they're basically trying to start with all the text on the planet. But there's two problems. First of all, people keep trying to use them in places where wrong is not okay. If you use it in a place where wrong is not okay, you are asking for trouble. And if you are somebody purveying that this can be used in an application where wrong is not okay, you are a bovine excrement artist. Because in that case, you aren't saying statements divorced from whether they are true or false. You are stating false statements. And then you are the swearing bovine excrement artist, not the philosophical bullshitter. So that's limitation number one. And that actually kills most applications. So like LLMs for programming, they're really good for autocomplete on steroids. That is, have the tab autocomplete be better at knowing what variable you want to use in this context. Although non-AI powered editors are still remarkably good at this.
Do you actually use AI? Do you actually use LLM assisted coding yourself?
Nope. Because it costs too much. And for me, the tab completed autocomplete on a editor without it works really well.
Yeah.
There have been some uses that do make sense. So prototypes. So you do not care about bugs. So when you're writing a prototype system, you don't actually care that it's correct. So if you don't care about your program being correct, it's great. I've got a colleague who will use it to generate proofs that are written in programming language. These work because you don't run the proof. You see if the proof compiles, and if the proof compiles, it axiomatically is a correct proof. And so it works for that. Or Google is having good luck using it for bug finding because you don't say the bug is here. You say the bug is here. Here's a program that will crash the provided input. And if the AI system crash doesn't work, you know it's bovine excrement. You toss it out, you try again. If it does work, it's basically a self-verifying thing that you have something that causes the program to crash. You have found a bug. And so it's good for stuff like that.
Fuzz tester edition.
Yes. Intelligent fuzz testing. Fuzz testing that's reproducible and easier to do. And
so what happens to OpenAI and Anthropic and all these guys? Because the thing about OpenAI is their entire, I think their pitch to the venture capitalists is, we have a system that will use all the money and all the electricity, and that is our moat. And that's what DeepSeek just absolutely took out.
Yes. So there's problem number one that the AI data center faces is that most of the applications are bovine excrement artists, not real. And so that market, yes, that market is not there. But for the ones where it is, you have the problem of a little lower quality really drops the cost. So DeepSeek claims that their latest foundation model, the competitor to the OpenAI flagship type models, cost them $5 million to train.
That's a lie, but
this is a lie. But even assuming they're discounting things by an order of magnitude, it would only be 50 million. Let's say they're discounting things by 2 orders of magnitude. It would only be 500 million, which is what OpenAI's burn in a month and a half, 2 months kind of thing.
Yeah, I mean, we'll get commenters, I'm sure, but no one can get good numbers on DeepSeek. and what its actual costs were. The register estimated the cost of hardware at 50 million. Other people have said DeepSeek's total hardware spend is 1.3 billion. How much you'd account to one model, I'm not clear on that. And DeepSeek themselves have said, we are theoretically profitable, which means we're not profitable. So nobody knows.
Yeah, nobody knows, but it's still, even the most, oh my God, they're spending a ton of money estimates are an order of magnitude or two less than what the OpenAI massive data centers are talking about.
Which
And
is
they've
how
got,
DeepSeek R1 crashed the NASDAQ
yeah, and
just by being released.
yeah, and the other thing is DeepSeek biases their models to things that can run smaller. So the DeepSeek R1 basically can run on a PC. The DeepSeek
Not fast, but
V3,
it can run.
yeah, the DeepSeek V3 latest, their flagship model with however many, 600 billion parameters. You can run it on a cluster of 6 Mac Studios. Um, because Apple has been quietly building massive machine learning accelerators into their phones and into their computers for almost a decade now. And so this poses the problem for the AI data centers that the market for inference isn't there. That is running the model. Because if you actually need to run the LLM on a significant basis, it doesn't take too many 200-seat a month subscriptions for you to go, I'm just going to do a Mac Studio cluster. And there'll probably be small startups that will do this for you and the like. You specialize the model. So once you're using an LLM, you go, I'm using an LLM for X. That means all the LLM effort that went to training on the stuff stolen from LibGen doesn't matter because it doesn't need to know anything about attack of the 50-foot blockchain, say. Um, and so you specialize the model, and there's companies doing this. So you take a big model like DeepSeek V3, shrink it down, and now you can run your entire enterprise LLM on a single Mac Studio.
What? I mean, companies don't actually do that. They would rather spend 10 times as much to have nothing on premises. But of course, that provides an opening for competitors.
Yeah, and the thing is that's 10 times as much to not run on premises, but still orders of magnitude less than what's needed to justify these data centers. Because
Mm.
the equivalent Mac Studio at Amazon is probably EC2 is grossly overpriced for this, and it's still only on the order of, say, $200 a day spend. And if you're talking $200 a day spend, you only need you only need 30 $200 a month subscriptions in the enterprise to make it make more sense. And
Yeah. One,
so,
one figure I've been told, this is an actual system someone made, um, 4 users, equivalent performance to ChatGPT Pro. They spent $35,000 a month at Amazon. That's expensive, but that's because Amazon doesn't always have the fancy NVIDIA rigs in all the regions always available. There's probably cheaper ways to do it, but this worked for an actual customer. Um,
and and Amazon is actually notorious for not discounting the older equipment. That most other providers getting the current
yeah,
year one is still going to be $100 an hour, but getting the 2-year-old model instead of still being $40 an hour, it's 5. That Amazon is unique in that their combination of extreme reliability and practical moats means that they charge way more in that space.
yeah. Amazon They charge a lot, but you get something that works,
Yeah.
and you'll pay.
Um,
And also you'll pay.
yeah.
I've been a sysadmin. I've had this as my actual problem.
Yeah, so have I. But then again, when 15 years ago, you have a network measurement application where your local sysadmin goes, so when are you getting on the front page of Slashdot? Your answer is, oh, we've been up there for an hour and all your stuff is running 5 by 5, and your local sysadmin never even noticed the traffic because everything
Uh,
was elsewhere.
okay. Right. So the bubble pops. What do you think will be left?
Empty buildings. Um, that if I was foolish enough to be one of these companies investing in these tens of billions of dollar data centers that burn gigawatts of power, I would not build it in the US. I'd build it in Mexico. Because if you build it in Mexico, you can import Chinese solar cells and Chinese batteries. And that way, when you're done, you have a gigawatt power plant that can run 24/7, built out in the Sonoran Desert and sell the power.
You'd use it for useful things. Do you think, I mean, coding models, I remember Tont, who's a common critic of a lot of things around tech. He refuses to be called a tech critic. He says he's a critic around tech. All his criticisms are political, but that's tech these days. He says that he pointed out that a lot of large language model coding assistants are going to get out of date. Give them a
I
few
don't
years.
I don't actually think that's as big a problem. A bigger problem with the coding assistants is what are they trained on? They're basically trained on all the code on GitHub. And the ratio of good code to CRUD on GitHub is yeah. If we tried to measure the ratio of CRUD to good code, we'd probably be approaching div zero overflow. Um,
And if it's anything special, you'll hit plagiarism. I know of a case. David Chisnell from FreeBSD talked about this. They had a particular driver someone wrote, and it was functionally the Linux driver. And of course, they couldn't use it for copyright reasons. And it turned out to have been done with a large language model. The For anything weird, the plagiarism problem is going to be big because there's one example to use.
the bigger problem with the LLM coding things that I see is they may suck for the real world, but they're really good for student assignments. And so if I was teaching now, I would have the problem of how do I lock down the students so that they still have Visual Studio Code with all the bells and whistles except the AI, because
It's a tricky one.
it's a tricky one. The other problem, the problem is though, is the train on crap problem. So like Tesla's self-driving will never work for various reasons, starting with Tony Stark himself. But one of the fundamental problems is let's build a machine model teaching people how to drive based on how Tesla drivers drive.
I hadn't thought of that one until you mentioned it, but yeah, let's train on the worst drivers in the world. Fantastic.
Oh, it could be worse. They could be Beamer drivers.
Oh boy. I'm so glad to live in London and not need a car. So I hire one every year or two, you know. Um, okay, I think that this is getting way longer than I usually do. Gosh, our first ever podcast interview on Pivot. So, Nick, where can people find you?
These days, about my only social media is Blue Sky, ncweaver.scarytech.com. There's a dash in it.
I'll put it I'll write it in the show notes.
And technically, I'm on LinkedIn, but I mostly use that for cyber stalking companies. LinkedIn's God's gift to open source intelligence. You want to
Have you
find
still
out
got a
who?
website with all your marvelous Bitcoin talks?
Yes, yes, I do have a personal website. It's on scarytech.com. It doesn't have most of my Bitcoin stuff because the problem is it just gets bit rotted away. But it does have my CV on it, which has links to all my papers, which includes links to formal stuff. Also, most of my non-technical writing ends up on Lawfare Media.
Yes, that was one of Nick's great successes, by the way, where you know how Tornado Cash, the Ethereum laundromat for money laundering, got busted. That was largely because of Nick's recommendation in a Lawfare article. So you
I
did the
don't
good work there.
I
Then
hope
Trump wound it
so. I
back.
wish it was, because if they were really reading it, they would have busted Tether back in 2018 for being the second coming of Liberty Reserve, back when it was a $2 billion second coming of Liberty Reserve rather than a $300 billion second coming of Liberty Reserve.
An amazing phenomenon. Oh, but yeah, crime is legal now, so it's fine.
Yeah, yeah. As long as
Anyway,
you're willing to bribe the president, he'll deny he knows who you are even when he pardons you.
I'm sure that it was all completely above board and nothing untoward happened except for all the crimes.
Yeah.
Anyway, thank you very much for this, and let's see how the audience feels about it. So, hello to the Pivot viewers and listeners. We will return on Monday with more Pivot. Thank you all very much. See you later, and bye for now.